Right, okay. Students, can you all hear me? Right. Okay. So, friends, good afternoon for everyone. And today we are going to conduct our first uh, official paper session, paper book number one, model paper number one. Right. First of all, I want to give you some brief introduction about how our paper class is going. Right. So, now this is the thing. Students, in our theory class, we are about to complete unit number one. Okay, unit number one, atomic structure. So in next month we are starting unit number two, structure and bonding, right? So in the first paper book, now we are going to discuss some paper book series. Okay, so some of the paper book series are there. Now 25 batches doing their 8th paper book, and 26 batches they are doing their third paper book. So now you started your first paper book, right? So in a paper book, normally, now in your first paper book number one, there are some model questions. Okay. In your paper book number one, there are 3 model papers. Model paper number one, model paper number two, and model paper number three in this. Okay. In each model paper, I have included 25 MCQs. 25 MCQs, 2 structured essay questions, 2 structured essay questions, and 2 essay questions. Okay. Now, remember, students, this is actually the phase one. That means this is just the beginning of the paper class, online paper class, right? So I have uploaded the first model paper to the WhatsApp group, okay? And you will get the printed paper book. For those who paid for the paper class, you will get those who registered for the paper class, you will get the paper book, printed paper book, along with the answer and review book. Okay, answer and review book means, students, actually I have given you some a book that is you can write down the answers on that book, and you can write down the reviews by yourself. I'm explaining all the questions here, so you can write down necessary what you want. Okay, in that book. Okay, understood. So there will be answer and review book. In that book only you have to write down the answers, and if you want to make reviews, you can write down the reviews. Review means you have to revise the theories. That means for each and every question there is a theory point. So you can write down that theory point along with that question. Okay. Now you have to understand that why we need a paper class. What is the reason for having a paper class? Now we are discussing theories in the theory class. We are discussing now in online class. We are discussing completely 3 hours theories. In the physical classes also, we are conducting completely theories. Sometimes I'm going to discuss questions also. Right. Along with that one, we have the memory booster paper discussion. I'll tell you that when we are conducting that memory booster paper discussion later. So likewise, we have some work, right? Different types of work. So the reason for having a particular paper class is actually you have to face for the examination by doing a lot of papers. Remember, students, most of the questions in my paper class paper books actually containing school term test papers, right? School term test papers questions, provincial paper questions, right? Some of the questions I got from the Indian books also there, right? Honestly, I want to tell you that these are the questions I'm going to include in this, and I'm going to discuss all the questions with you. So I'm the one who preparing answers, the discussion. So I have just questions only. I'm going to give you the answers. We are discussing. But the thing is, before you attend for the everyday paper class, my advice is try these papers before you attend for the paper class. Try these questions. In the phase number 2, we are writing the papers through online. That means I'm going to give you a separate time slot through online. You have to write down paper. You can turn on your camera and you can write down that paper at home and you have to upload the answers, right? And then in the discussion, so I'll tell you how the marks are allocated, so you can check your answers, right? So likewise, that's the way that we are conducting our online paper class, right? The main intention is actually to practice you to face for the examination by writing papers, because learning theories doesn't guarantee that you will get higher marks, good marks in the exam. But if I say like this, I want to say like this: if you learn theories properly, plus if you do some papers, model papers, good questions before the exam, it guarantees a good result. Otherwise, just learning theories, it's actually incomplete students. Right? You have to do a lot of questions. Now we know that A-level examination is also so competitive. So therefore, you have to do a lot of questions, right? So therefore, I'm discussing these kind of questions with you in the paper class hereafter. So paper books are sent. You will get the paper book next week, the printed paper book. There are 3 model papers. I just uploaded 1 model paper. So the 2 next model papers will be uploaded. The complete PDF will be uploaded. Okay. And I'm going to prepare a separate WhatsApp group for that one, for the paper class separate. So you can join for that one. So that's the way we conducted paper class, and our time for now is actually Saturday 1 p.m. to 3:30. Sometimes it can be 1:30 to 4 p.m. also, 2.5 hours. When I want to expand the time, definitely I'm going to expand the time. From the next year onwards, sometimes I might expand the time, right? Now this is just the beginning, so therefore let's do the paper class in this way. Okay. So and the next thing is actually don't depend on the recordings. Always try to attend for the paper class for the live sessions if you don't have any other works, and do the paper here and finish that work here, and then you don't have to worry, you don't have to watch the recordings, don't collect the recordings, no point, right? So the first paper book is made by unit number 1, atomic structure. So the second paper book actually will be made with unit number 2, I think. Yeah, we have to start unit number 2 next week. So in that paper book, you will see unit number 2 questions also, right? So my main intention is to prepare you for the A-level examination by doing a lot of papers, different kind of questions, and we are discussing all the questions here. And I want you to prepare for the term test examinations as well, right? Because take the advantage of the paper class, because students, this is actually what school term test papers. So these questions only they are repeating in every year. Small differences are there. So take the advantage of this one and get ready for the your first target is actually first term test examination. So let's take something from here. Along with that one, we know that memory booster is also there. So MCQ discussion. So from that one also you can do something, right? So along with that one, theory class is ongoing. Past paper discussion will be started when the unit is completed, right? So likewise, please get ready now by doing papers. Okay. Right. These are the things I want to discuss about the paper class. And if you have any doubts, anything that you want to know, let me know. Then let's move to the paper book number 1. Paper book number 1, model paper number 1. Right. Okay. First of all, let's move to the MCQ paper. Let's move to the MCQ paper. So as in this MCQ paper, there are 25 MCQs to discuss. And I have given you some answer sheet also after the 25 MCQs. So when you get the paper book, you can see that one. So let's see. What are the questions that we have to discuss? So you can write down a theory point if you want. It's not compulsory. I'm not asking you to write down the reviews. It's not compulsory, but if you want, you can write down the reviews by yourself. The main thing is understanding the question, how to answer for the questions, because in the examination, they are not asking the reviews. Okay. So reviews, write down the reviews if it is necessary. It's not compulsory. Yeah. Right. Question number 1. Name the each scientist and their activity is correctly mentioned in. So they have given the table, the charge of the electron, radioactivity, neutron, and quantization of energy. Right. So what is the theory point that we learn for this question? Right. In your review book, you can write down like theory point and you can revise everything. Charge of the electron. The charge of the electron found by whom? And this was radioactivity. Radioactivity found by whom? Then who discovered the neutron? Right? Then students, quantization of energy. Right? So they have given name each of the scientists and their activity correctly mentioned in. So tell me, students, who found the charge of electron? Put your answers in the chat box. Yeah, it is Robert Millikan. It is Robert Millikan. Then you can see that the Millikan is given in second option and the third option, right? Then the next one, radioactivity. So who found the radioactivity? Henry Becquerel. Henry Becquerel. So we learned that one as Henry Becquerel. Then you know that what is the answer for this one? Question number 1, answer is 2. But anyhow, tell me what is who found the neutron? Who is the scientist related to the neutron? Students, neutron was found by James Chadwick. James Chadwick. We know that the experiment conducted on finding neutron was beryllium plate is bombarded with alpha particles, but this is famous nuclear reaction, and then it is producing carbon 612 isotope, and neutron is released. So this is the reaction for finding neutron. Beryllium plate is bombarded with alpha particles, and neutrons are produced along with the carbon 612 isotope. Then quantization of energy. Energy is quantized. Who said that? First of all, the idea is given by whom? Max Planck, right? Students, we did some calculations. Can you remember in the unit number 1? Using the equal h nu. This is the main one of the main assumption that made by Max Planck in his quantization theory, quantum theory. Energy of a photon is directly proportional to the frequency, right? Energy is consisting small particles, small energy packets. So those were known as photons later. So energy of a photon is directly proportional to the frequency. Then this proportionality symbol can be eliminated by adding a constant, that is h. H is considered as the Planck's constant. Planck's constant value 6.022 10 to the power minus 34 joules seconds. Right? So revise everything that we learned in our unit number 1. Okay. Then, so this is actually Max Planck. Robert Millikan, Henry Becquerel, James Chadwick, Max Planck. This option is given in the number 2. Question number 1, answer is number 2. Raise your hand those who got the answer correctly. Okay. So this one should be 6.626. 6.626 10 to the power minus 34 joules-seconds, right? If you have any doubts, put your doubts in the chat box, right? The first term test questions will be this depending. In your school, sometimes they might only include unit number 1 for the first term test. Sometimes they might include chemical calculations also, structure and bonding also, right? Some schools are starting unit number 2 without doing unit number 1. They are starting unit number 2. Sometimes they are starting unit number 3. Now there is a student in physical class, St. Peter's College. So in his school, they have completed unit number 1 and unit number 3. So the exam is also conducted from the unit number 1 and unit number 3. Okay. It's not fair actually. They have to complete unit number 2 first of all, but some of the agendas are there for schools, right? We can't go like in school. Actually, our target is not the school. Our target is A-level examination. So therefore, we are preparing for that. Which of the following electromagnetic radiations has the highest wavelength? Students, they are talking about the electromagnetic spectrum. So can you remember electromagnetic spectrum? Right? Let's go in the correct order. Electromagnetic spectrum. Under the electromagnetic spectrum, we learned that we are starting from TV and radio waves, right? Then students, radar, microwaves, right? Infrared, okay. Then visible light, ultraviolet, UV, X-ray, gamma rays. So this is the electromagnetic spectrum. TV, radio waves, radar waves, microwaves, infrared, visible light, UV, X-ray, gamma. And you know that for this direction, from TV, radio waves to gamma rays direction, what will happen to the energy and the frequency? Energy and the frequency both increase. Then what will happen to the lambda wavelength? Lambda wavelength is decreasing. So the wavelength is decreases, right? So this is what we consider as the electromagnetic spectrum. And we know that visible light is actually having 7 colors. We discussed that one. So we know that which one is having the highest frequency? Gamma, right? So we can see that gamma rays are having the highest frequency and the lowest wavelength, lambda. Then TV and radio waves has the highest wavelength but lowest frequency for that one. Then they are asking which of the following electromagnetic radiations has the highest wavelength? They have given ultraviolet, visible, infrared, microwave, radar waves. So we have to choose radar waves. Question number 2, answer is number 5. Question number 2, answer is number 5. Raise your hand those who got the answer as number 5. Quickly raise your hand those who got the answer as number 5. Very good. Very simple, huh? Right. Then third question is related to the electronic configuration. So we have discussed about electronic configuration. Let's go for that question quickly. Complete this one. If you want to note down anything quickly, note down now. Little by little, I'm increasing the speed of the discussion. Now, since this is the first discussion, I'll expose smoothly. Now you have to increase the speed. Huh? Right. Okay. Now, question number 3. Question number 3. The electronic configuration of the ion in the molecule of FeO, right? So that question is should be like this: the electronic configuration of the ion in the molecule of FeO. Correct that one. You have to cut that. The electronic configuration of the ion in the molecule of FeO. The correction should be like this: the electronic configuration of, they have given like this name, the ion O ion. Cut this one in the molecule FeO. Okay. Then students, look at this one. So this is actually considered as ferrous oxide. Okay. If you don't know, write down the name. So the name of this compound is ferrous oxide. Can you remember I told you when we write down the electron configuration, iron is producing two cations. One is Fe2 plus and the other one is Fe3 plus. This is considered as ferrous and this is considered as ferric. Ferrous and ferric. So this is ferrous oxide. That means, students, the cation is Fe2 plus. They are asking the electron configuration of iron in the molecule FeO. Then you have to understand here, this is not the iron atom. This is the cation ferrous. Then we have to choose the answer of the electron configuration of cation, not the element ion, atom ion. So therefore, when we consider Fe, what is the atomic number? 26. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 3d6, 4s2. Then if it is producing Fe2 plus cation, ferrous cation, what is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. These two electrons are removed. So they're asking about the electronic configuration of this Fe2 plus, right? Not iron atom. Because in the molecule FeO, we have the cation. In that case, what should be the answer? 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 is given in the option number 5. Question number 3, answer is number 5. Raise your hand those who got the answer. Good, very good. So this is about the electronic configuration, no? Right, are we done? Now let's move to the question number 4. Select the element shows a positive electron gain energy, right? So we didn't learn that theory yet. In the next week classes only we are learning this theory, electron gain energy. But that's very simple. I'll teach you that one. You can learn that one now. It's not that much of a big deal. Look at this one. Students, electron gain energy means the energy that is related when the electrons are gained. Can you remember the opposite of this one that you learned? What is the opposite of electron gain energy? As a theoretical concept, what is the opposite of electron gain energy that you learned? Can anyone answer me? What is it? Yeah, losing electrons. Gaining electrons, opposite is losing electrons. So losing electrons is considered as, electron losing is what? Ionization, right? Electrons removing, losing. So therefore ionizing. Ionization means electrons are removed. So electron gain energy means, now look at this one, okay? Electron gain energy, EG, electron gain energy. Now just imagine there is an element X, right? Taking one electron and producing X minus gas. This is what we consider as electron gain, the process of electron gaining. This is the related energy for this one is considered as electron gain energy, delta E, Eg, right? This is the first electron gain energy, right? So gaseous state atom, neutral atom is taking 1 mole of gaseous state neutral atom, taking 1 mole of electrons to produce single valent gaseous state anion at the standard state, 1 mole of a single state gaseous state anion at the standard state temperature and pressure is considered as first electron gain energy. The same definition we gave for the first ionization energy, same type, right? So this is what we consider as the electron gain energy. So in the electron gain energy, what are the main things, what are the points that you have to remember, right? What are the theoretical points that you have to remember? Remember students, electron gain energy can be negative or positive, right? Electron gain energy can be negative or positive. There is a value, that value can be negative or positive. Just imagine if the electron gain energy is a positive value, right? If it is a positive value, we consider that reaction, that process is endothermic, right? Students, endothermic means it is absorbing the energy. Got it? Endothermic means absorb the energy, right? Electron gain energy, if it is a positive value, endothermic, that means absorbing energy. If it is a negative value, then it is considered as exothermic. Exothermic, that means it releases energy. It releases the energy. Can you understand? It releases the energy. Then what else we have to know? When we consider most of the elements, most of the elements in the periodic table, elements have negative values, right? Negative values for the electron gain energy, right? Let me write down here first electron gain energy. First electron gain energy. First electron gain energy. Most of the elements, huh? But some of the elements are there, right? Remember these elements, students. Second period beryllium, second period magnesium, second period beryllium and magnesium. So we can consider second group, even second group is also correct. Beryllium and magnesium belong to group number 2. And nitrogen in group number 50, right? Beryllium, magnesium, nitrogen. They are having positive electron gain energy values, right? Have positive value for the first electron gain energy. Okay. Now this is the point that is important for the answering the question that they have given. Beryllium, magnesium, and nitrogen. Remember, students, we are not discussing about the electron gain energy for the noble gases. Why? In some books, they have given electron gain energy 0. That means noble gases are not taking electrons. Unnecessary thing. Because noble gases are having a stable configuration. So why they should take up electrons? Right? So that is unnecessary thing. In some books, they have given that electron gain energy of the noble gases are positive values, highly positive values. That means, students, endothermic means we have to do a work. Right? It is absorbing the energy means we have to do a work. It is difficult. Exothermic means the reaction itself is releasing energy. Right? We don't have to do anything. So for the noble gases, if we are giving electrons, it's very difficult because they are not accepting those electrons because of that stable configuration. So likewise, beryllium, magnesium, nitrogen is also behaving in the same way. Do you know why? Beryllium is having a configuration like, so what is the beryllium's configuration? 1s2, 2s2. What is the magnesium's configuration? 1s2, 2s2, 2p6, 3s2. This S2 configuration is stable because that sub-energy level is completely filled with the electrons. Right? Beryllium, magnesium. So these actually fill with the electrons. These things are filled with the electrons. Right? Are there any unpaired electrons in beryllium, magnesium? No, right? So S2 configuration we consider stable. Then nitrogen, 1s2, 2s2, 2p3. Plus this p3 configuration is also stable. How? Because p3 configuration is half stable. So since it is half stable, we can say that it is also stable. So beryllium, magnesium, nitrogen, they are showing positive values. So then what about phosphorus? No, students, right? We only consider about these elements, beryllium, magnesium, and nitrogen. Phosphorus are having negative values, not the positive values, even though there is a stable, half stable configuration. Beryllium, magnesium, nitrogen, because of their stability, it's not that much of stable, it is somewhat stable, have positive values for the first electron gain energy. Beryllium, magnesium, nitrogen. Okay. And the next theoretical point that you have to learn about the electron gain energies. Remember, students, second electron gain energy is always positive value. Right? X minus gas is taking one electron to produce X2 minus gas. So this is considered as delta E Eg2. Delta E Eg2. Remember, this is always a positive value. Always positive value. That means endothermic. We are learning about this electron gain energy again in the unit number 5 also, enthalpy. Okay, in enthalpy lesson. And there also we are learning. So this is a positive value, second electron gain enthalpy. Can anyone tell me a fair reason why this second electron gain energy should be positive? Right? You should not. You should not know anything about this thing. Right? Think practically and tell me why the second electron gain energy should be positive value as you think. I need your opinion. Anyone? Yes. Amani, your answer is correct. That is the answer. What about the others? Why second electron gain energy is positive value? No. Can anyone tell me the reason again? Right? Let's learn about this one in the theory class again. Joella, no. Yes, Vinudi, your answer is perfect. That is the answer. Remember, students, now look at this one. After giving electron for a, now this is negatively charged. So we are giving an electron for negatively charged species, right? So therefore, around capital X, we know that now in this element there is a negative electric field. So when we are giving electron for that negative electric field, will it accept or refuse? It will refuse. Why? Because negative always repulsions are taking place. Same charge. So when the same charge meet each other, they will repel. So therefore repulsion will take place. Then we have to give more energy to give that electron. Right? We have to give that electron in very difficult way. Energy is consuming. Right? We have to consume energy. So therefore the reaction is absorbing energy. So therefore what will happen? Second electron gain energies into third. Positive value. The reason is electron repulsions. Now this is neutral atom solder. For the neutral atom, we are giving electron. So there is no charge here. No issue therefore. The only affecting factor is if the electronic configuration of capital X is stable, then it is difficult to give the electrons. For an example, beryllium, magnesium, nitrogen. When we are giving electrons for the negatively charged ones, so then it is producing this kind of thing. Can you understand? Right? So, right. So these are the theoretical points that you have to remember. I will write down that one again here. Second electron gain energy, right? Second electron gain energy. Second electron gain energy is a positive value. Always positive value. Okay. Right. Then tell me, students, question number 4. Select the element shows a positive electron gain energy. Chlorine, sodium, nitrogen, fluorine, aluminium. We have only 3 elements, students. Beryllium, magnesium, nitrogen. Then answer is nitrogen. Question number 4, answer is third one. Question number 4, answer is third one. Quickly note down these things if you want. If you have any doubts, put your doubts in the chat box. Yeah. So why we are talking only nitrogen, beryllium, magnesium for positive electron gain energy? Because these three only positive electron gain energies. First electron gain energy is positive for only these three elements according to the data tables that they have provided. Okay, so other elements are having negative values. Okay, so remember students, now these electrons actually are more attracted to the nucleus also. So when we don't know that when we go down the periodic table, there are so many electrons, right? So therefore, for those things actually, even though the electron configuration is stable, we can give electrons. That's a negative value. For beryllium, magnesium, and nitrogen, they have found those things are positive value. That means we have to give energy. And especially noble gases also we consider positive values. Okay. Question number 5. Let's discuss about this electron gain energy part again in the theory class. Okay. So here I have given you the theoretical point for the question. Now students, question number 5. Which is not true regarding the modern periodic table. Majority of the elements present in the periodic table are metals. Remember students, regarding the periodic table, we discussed many things. I told you that 80%, right? 80% of the elements in the periodic table are metals. So therefore, the first statement is correct, right? Majority of the elements present in the periodic table are metals. The first statement is correct. Second statement, among the elements of the P block, there exist the elements belong three states of solid, liquid, and gas. Among the elements of the P block, there exist the elements belong to three states of solid, liquid, and gas. What do you think? Is that correct? Is P block containing solid, liquid, and gas? All three states of matter. Is that true? Yes, that's true. Can you remember I told you group number 17 is the only group which is having all three states of matter: fluorine, bromine, iodine, astatine. Right? Fluorine, bromine, iodine, astatine. Can you remember? Right? So these two are gases. Fluorine and chlorine, these are gases. And bromine is a liquid. Iodine and astatine, so these are considered as solid. Can you understand? So group number 17 belongs to P block. So therefore the statement that they have given, what is the statement? Among the elements of the P block, there exist elements belong to three states of solid, liquid, gas. Right? So therefore that statement is correct. Third statement, the modern periodic table is prepared based on the atomic number. Is that correct? Yeah, I told you that modern periodic table is based on atomic number and the electronic configuration. So they haven't mentioned the electronic configuration, but they have given atomic number. So therefore this is correct, partially correct. Okay. Let's go for the other statements as well. Nuclei of all the elements of the periodic table have protons and neutrons. Is this statement correct? Nuclei of all the elements of the periodic table have protons and neutrons. All the elements are having protons in the nucleus. Right? So atomic number means number of protons, starting from hydrogen to organism. All the 118 elements are having protons in the nucleus. That's true. Right? Then what about the neutrons? There is only one element in the periodic table which doesn't contain neutron. What is it? Hydrogen. Then is this statement correct? Wrong. Fourth statement is wrong. Number 4 is wrong. Number 5. Within first 6 periods of the periodic table, there are 11 elements which exist in gaseous state at the room temperature. Yes, that's correct. Right? We know that only 6 periods are there in the periodic table. So there are 7 periods. There are 7 periods. And within 6 periods of the periodic table, there are 11 elements. Yeah, up to the radon we can consider. So what are the 11 gases in the periodic table? What are the 11 gases under the periodic table we discuss? Let me start from the period number 1, hydrogen, helium. Okay. Then in the second period, we have nitrogen, oxygen, fluorine, neon. And then when we go for the third period, we have chlorine, argon, krypton, xenon, radon. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 gases are there in the periodic table. So therefore that's true. That statement is true. So here this one also can be considered partially correct. Anyhow, fourth one is wrong because of that neutron statement. So question number 5 answer should be fourth one. That is from the periodic table. See, I told you they won't ask what are the elements in the periodic table, right? So they will ask these kind of statements. I told you, you have to analyze the periodic table. What are the solid elements? What are the liquid? What are the gases? What are the metalloids? What are the amphoteric elements? How many periods are there? How many groups are there? Likewise, what are the block-wise classification? So that analysis part should be done very carefully. So since we have discussed those things, this question is nothing. Question number 5, answer will be 4. Right, okay, now raise your hand those who got 5 out of 5 correctly. Those who got the answers for all 5 questions that we discussed. 5 out of 5. Okay, good. There are many. Fine. Now let's go for the question number 6. Considering the following informations, answer the questions number 6 and number 7. The radiation having a frequency of 656 nanometers causes to form the first line of Balmer series of the atomic spectrum of hydrogen. So Planck's constant is given as 6.62 10 to the power minus 34 joules. Students, Planck's constant unit is wrong. Correct that one as 6.62 10 to the minus 34 joule seconds. Velocity of light is 3 into 10 to the power 8 meters per second. Select the suitable energy levels of hydrogen atom to occur the relevant electron transition to form the above mentioned line. Okay. Okay, first line of the Balmer series, what is it? N equal 3 to 2, right? First line in the Balmer series, can you remember? Right, this is H alpha, H beta, H gamma, and this is H delta. Right. So we can consider that H alpha is red color, H beta green color, H gamma blue color, H delta is violet or purple. So this is the electron transition from 3 to 2. This is 4 to 2, 5 to 2, and n equals 6 to 2. So likewise, some electron transitions are there. Then as they have given from the first line of the Balmer series, so therefore we have to consider that n equal 3 to n equal 2. So question number 6 answers first one. That's very easy. Balmer series first line. Question number 7. The energy of a photon of the above radiation with that wavelength kilojoules is, right? Energy of a photon. Plus, energy of a photon can be calculated equal h-nu equation. Can you remember? Then frequency is not given. They have given the wavelength. So therefore, we can use equal hc over lambda. Right? We can derive this equation from equal h nu and c equal mu lambda. In theories, we have discussed this one. Okay. Then, so what is the Planck's constant? 6.62 10 to the power minus 34 joules. And velocity of light 3 into 10 to the power 8 meters per second divided by 6.56 10 to the power minus 7 meters. Meters will cancel off. So this one should be joule seconds. Per second, second will cancel off. And here equal. Students, look at the answers they have given. Now you don't have to go for the logarithm calculation. Okay. We don't have to go for the logarithmic calculation. Right? We don't have to go for the logarithmic calculation. Now, all the answers that they have given is 3 to the power something. 3 into 10 to the power something. All the answers are 3 into 10 to the power something. That means 6.62 divided by 6.56. They have approximately taken that one as 1, cancelling off. Approximately, okay? Approximate answer. Then 3 into, this is 10 to the power minus 7. We'll go for the numerator as 10 to the power plus 7. Minus 34, 10 to the power plus 15. And here joules. Then what is the answer? Energy of a photon, 3 into 10 to the power minus 19 joules. So 3 into 10 to the power minus 19. Right. So there is a small error. The third answer, they have given 3 into 10 to the power minus 9. That should be corrected as minus 19. Okay. Actually, the answer should be third one. Anyhow, tell me those who got the answer by doing a calculation, those who got the answer as 3 into 10 to the minus 90. Then okay, ne? You got the answer as 10 to the minus 9. But if you have got the answer like that, then answer is correct. Question number 7, answer is third one. Please correct that one. Answer should be 3 into 10 to the power minus 9. It's not 9, minus 90. Okay. So this one is actually from the hydrogen emission spectrum and the energy analysis. Right. Now let's move to the question number 8. Question number 8. Which of the following is not a property of cathode rays? When an electric field is applied in the path of them, they attract to the positively charged plate. When an electric field is applied in the path of them, they attract to the positively charged plates. Yeah, that's true. Okay. Second one, for the cathode rays obtained from the different gases, E over M ratio is constant. Yes, students, that's correct. For the cathode rays, E over M ratio is constant, whatever the gas we use, right? Whatever the gas, whatever the metal that we are using inside the cathode ray. So therefore, this is true. It deflects towards the north pole at a magnetic field. That's wrong. I told you that normally cathode rays are electrons actually deflected perpendicular to the direction of the magnetic field. They travel in a straight line. This is the second experiment conducted by J.J. Thomson. Right, cathode rays travel in a straight line like light. Okay, can you remember that in front of the cathode ray, he kept an metal cross and he observed the shadow of the metal cross with sharp edges, exactly similar in size, at the opposite side of the cathode ray tube. So that's correct. Number 5. The nature of the cathode rays does not depend on the gas inside the cathode ray tube or cathode material. Yes, of course. Right? That's correct. So they're asking which of the following is not a property of cathode rays. So answer is third one. Question number 8, answer is third one. Raise your hand those who got the answer. That is very simple, right? Question number 9. Question number 9 is quantum numbers. The maximum number of electrons possible in the sub-energy level given by L equal 3. Right? Friends, shall we revise theory part of the quantum numbers quickly? Again, quantum numbers are very easy. We know that quantum numbers are used to define the location of electrons. And there are 4 types of quantum numbers. What are they? Principal quantum number, azimuthal quantum number, angular momentum quantum number, and the spin quantum number. Principal quantum number, azimuthal quantum number, magnetic quantum number, and the spin quantum number. Principal quantum number is representing the principal energy level. And angular momentum quantum number is representing the sub-energy level. And magnetic quantum number is representing the orbital type. And here the spin of the electron, right? So here, principal energy level, and this is sub-energy level, subshell, and this is orbital type, and here spin of the electron, okay. So here principal energy level, principal quantum number can have the values from 1, 2, 3 likewise. Sub-energy levels can have values 0, 1, 2, okay. And orbital types, when we consider spin magnetic quantum number, we can have like, for an example, -3, -2, -1, 0, +1, +2, +3 likewise. And for the spin quantum number, we can have +half or -half. Now here they have given L equal 3. L equal 0 means S sub energy level. L equal 1 means P sub energy level. L equal 2 means D sub energy level. L equal 3 means F sub energy level. Thus here, so here we have to consider that students, in the question number 7, yes, they are asking the energy of a photon of the above radiation with that wavelength kilojoules, right? Again, come back to the question number 7. We calculated that energy of a photon is 3 into 10 to the power minus 19 joules. So in kilojoules, how much? You have to multiply this one by 10 to the power minus 3. Therefore, answer is 3 into 10 to the power minus 22 kilojoules, right? Okay. Okay, anyhow, if you got the answer like this, your answer is correct. In the third one, question number 7, third one should be corrected as 3 into 10 to the power minus 22 kilojoules. Now, okay, right? If you got the answer in this way, your answer is correct. Your answer is correct. And correct the third one, correct the third answer, 3 into 10 to the power minus 22 kilojoules. Okay, right? Then tell me, students. Now let's go for the question number 9 again. The maximum number of electrons possible in the sub-energy level given by L equal 3. So L equal 3 means F sub-energy level. So in the F sub-energy level, how many electrons can be there? Maximum 14. So therefore, question number 9, answer should be number 5. Question number 9, answer should be number 5. Question number 10, the atomic number of selenium is 34. The correct orbital diagram of electrons which are present in the valence shell is, right? Friends, look at the 5 answers they have given. OS2, in this OS copy. Is this electronic configuration the way that electrons are filled to the orbitals? Is that correct? Is this following the Hund's rule? Students, what does mean by the Hund's rule? Can you remember? Revise it again. Hund's rule means when the electrons are filled to the orbitals, first of all, the parallel spin, that means same spin electrons are filled to the orbitals. Then only the second opposite electron, the paired electron, is filled to the orbital. According to that way, this answer is wrong. Okay, so there are 4 electrons. So the third electron should go for the third orbital, the remaining unoccupied orbital. So therefore, this answer is wrong. Second one, OS 4p. Friends, consider these three actually a half-headed arrow, right? Just consider those things are half-headed arrow, right? Then according to that, second one, right? Let me draw the others also. Number 3, consider these things as half-headed arrow. So here 2 arrows are given. Made upward, downward, both are given. And here 4D also given. Right, okay. Friends, what about the second one? Is this correct? Second one, this orbital diagram, is this following the Hume's rule? What do you think about the second one? Why second one is wrong? What is the reason? Tell me the reason why second one is wrong. Those who are telling that second one is wrong, give me the reason quickly. It should fill in 3 orbitals first. Let me see your answers. It should fill all the 3 orbitals first. There is only 3 electrons. It should be 4. There are 4 electrons in p sub energy level. 4 electrons. Okay. Good, good, good. Very good. Selenium 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p4, right? Now this is the configuration, 4s2, 4p4. Then only 34. In the sub energy level, there are 2 electrons. In the p sub energy level, there are 4 electrons. 1, 2, 3, 4. So 1 electron is missing, as you say. Wrong. D sub energy level, can't consider. What about here? S sub energy level is having unpaired electron, can't consider. What about the 5th one? Yes, this is the correct answer. Question number 10, answer should be number 5. Question number 10, answer should be number 5. Right. Raise your hand, those who got 10 out of 10 correctly. Quickly raise your hand, those who got 10 out of 10 correctly. I want to know. Senuki, Rushma, Misra, Shehani. Only that. Only 4 students. Again, raise your hand, those who got 10 out of 10. Okay, right. So these are the first 10 MCQs, okay? Now let's go for the question number 11. Right, okay. Now let's move to the question number 11. The variation of atomic radius, first ionization energy, electronegativity across a period left to right and down a group of the periodic table is correctly given by. Okay, students, you know how that atomic radius is varying along a period and along a group top to bottom. First of all, let's consider a longer period. Second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. In this way, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So along a period, atomic radius decreases. Atomic radius decreases along a period. Right? So the reason actually we learned that effective nuclear charge is increasing for that direction. Nuclear charge is increasing. Okay, so therefore atomic radius decreases along a period. Then what will happen to the atomic radius down the group? Right? Lithium, sodium, potassium, rubidium, cesium. So what will happen? Down the group, remember students, atomic radius increases down the group. Atomic radius increases down the group. Remember that. Okay? So what is the reason behind that atomic radius is increasing down the group? Number of energy levels are increasing. Number of energy levels are increasing. When we consider lithium, there is only 2 energy levels. When we consider sodium, there are only 3 energy levels. Potassium, 4. Rubidium, 5. Cesium, 6. Since the number of energy levels are increasing, shielding effect. Can you remember we discussed about the shielding effect? Shielding effect is increasing. Right? So therefore, the atomic radius is increasing down. So this is what you have to understand about the atomic radius, how that atomic radius is changing along a period from left to right, and along a group top to bottom, what will happen to the atomic radius. Then students, let's go for the ionization energy. Right? In the online class, actually, we didn't discuss ionization energy. In physical classes also, in some classes, actually, we didn't discuss ionization energy. Now look at this one. First ionization energy. First ionization energy. First ionization energy. So let's see that first ionization energy graph. Right, in all over time also you learn. Okay. Remember students, the highest first ionization energy belongs to helium. Then next one is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Students, now these actually what? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These elements are in a particular period, second period elements. In a period, can we say a proper variation for the first ionization energy? Can I say first ionization energy increases along a period from left to right? Can we say like that? No. We can't say like that. There are 2 factors affecting to the ionization energy. Don't worry, we are going to discuss this thing in the theory class. Now just listen to these things, okay? You will understand these things after learning these things in the theory class. I'm briefly explaining. Ionization energy is depending on the atomic radius and the electronic configuration. When the size of the atom increases, ionization energy is decreasing. Why? Ionization energy means simply the energy required to remove the electrons from the valence shell. So that required energy is decreasing by increasing the size of the atom. Right? Students, if I ask you, this is lithium and sodium, from which atom we can remove the electrons easily? Is it lithium or sodium? Sodium. When the radius increases, it's easy to remove the electrons. When the atomic radius increases, first ionization energy is decreasing. Understood? That's what you have to understand. But there is another factor affecting. Now when we consider growth, now when we consider period-wise elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, I told you that atomic radius is decreasing. Then ionization energy is increasing for that direction. Ionization energy should increase for that direction. Okay. Try to understand, students. When the size increases, ionization energy should decrease. When the size decreases, ionization energy is increasing. So this is what we expecting. This is the expected variation for the ionization energy along a period. But remember, because of some stable configuration like beryllium, nitrogen, so they have greater ionization energy like this. Beryllium's configuration is also stable, 1s2, 2s2. This is somewhat stable. Nitrogen's configuration 1s2, 2s2, 2p3. So this is also somewhat stable because p3 configuration is somewhat stable. Right? Yeah, second group and the 15th group. So you learn this one in O-level time, right? If your science teacher taught this one properly, now actually you should understand this. You should be able to understand this one. Right? Beryllium, nitrogen. So they are having stable configurations. Right? S2 configuration and 2p3 configurations are stable. So that's why beryllium's ionization energy is greater than boron. Suddenly it's increasing. The expected variation is look like this. This is what we are expecting. Right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This is what we are expecting. But anyhow, right? This is the exact variation. Why? Beryllium and nitrogen. So both of the elements are having stable configurations. Okay. In this way. Now, when we consider the third period, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Right? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Hydrogen and oxygen are actually in the same way. Actually, oxygen is little bit greater, but we can say that it is in the same level. So let's analyze the values in the theory class. Okay, I'll teach you. Next Wednesday, we are learning those things in the theory class, online theory class. Can you understand? So we can't discuss about a proper variation for that first ionization energy, students. That's wrong. We can't discuss a proper variation along a period, but down the group we can say, right? Down the group, since the atomic radius increasing, since the atomic radius increases down the group, what will happen to the ionization energy? First ionization energy decreases. Down the group, it's okay. Can you understand what I'm saying? Raise your hand those who understood the concept of the ionization energy variation that I taught you now. Honestly, raise your hand. And if you have any doubts, put your doubts in the chat box. I didn't teach you these things in the theory class yet, okay? Don't worry. But you should be able to understand. Is this difficult? So you explained this in the theory class. Okay. Okay. I can't remember exactly, right? It doesn't matter. Right? Can you please draw this graph? Okay. Draw this one again. Practice this one. Now let's see how that second period and third period, the variation is going. Now this is actually a rough sketch, right? That means students, we don't know whether exactly carbon or sulfur has the largest value. So that can be learned when we are studying the data table. Okay. I'll give you that variation data. Now you have to analyze this one separately and this one separately. Okay. Don't go for a comparison between these two elements. For an example, oxygen and phosphorus, because these are two different periods. In this graph, we can't go for a comparison like that. Okay. This is kind of a rough sketch. I'll give you the exact values. Right. Okay. Then students, this is what you have to understand as the summary. First ionization energy along a group top to bottom, it is decreasing. From left to right along a period, we don't have any increasing order or decreasing order. We have zigzag variation. Okay. Zigzag variation. Right. Then students, they have given another property like electronegativity. Okay. We didn't discuss this one, electronegativity, and we are about to discuss this one in the next class. Electronegativity means what? Again, you have learned this one in all over time. So you are telling every time now you have learned these things on all over time. What is the meaning of this one? Oh, you should be able to remember these things now. That's what I'm asking. Can anyone tell me what does mean by the electronegativity? Idea. What does mean by electronegativity? You know it. Yes. Anyone? Yes. Within. So these are the answers. You are correct. You all are correct. Ability to pull the electrons from another atom. It is known as electronegativity. Remember, students, the electronegativity is actually given by Now they have assigned a value, right? So this value is actually known as electronegativity value. The value is given in the Pauling scale, right? So there was a scientist known as Linus Pauling. So he is the one who constructed this one. He gave a numerical value to measure the electronegativity, right? Now I will teach you a short method now. In the theory classes, I'll teach you again. Don't worry, in the paper classes, we are repeating these things again and again. Right? Then I want you to I want to put these things into your head. When we do these things again and again, actually automatically these things are going to your head. Pauling scale. There is a short method. Okay. Now look at this one. Hydrogen here, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And we are not talking about the electronegativity for the neon, noble gases, because they are not forming chemical bonds. Right? You just remember these values. These values I know. Then sodium, magnesium, aluminium, silicon, phosphorus, sulfur, fluorine. Students, who is the most electronegative element in the periodic table? Tell me. That is fluorine. According to the Pauling scale, fluorine's value is 4.0. Right? Now go for this side. You have to decrease the values by 0.5 by 0.5. Right? Decreasing the values by 0.5 by 0.5. Then tell me what is the value for oxygen? 3.5. Nitrogen, 3.0. Carbon, 2.5. Boron, 2.0. 1.5, 1.0. You understand? In this way. Then students, remember, when we consider the electronegativity of chlorine and sulfur, chlorine's electronegativity is lesser than one value of fluorine's. What is the one value less than this one? 3.0. What is the one value less than for this one? 2.5. Okay. After that, remember hydrogen and phosphorus both are having the same electronegativity values, 2.1. 2.1. Then students, hereafter all the values are decreased by 0.3 by 0.3. Here 1.8, 1.5, 1.2, and this is 0.9. In this way, you can see that it is decreased by 0.3 by 0.3. This is the way that we can remember the Pauling scale electronegativity values. Okay, I'll teach you this one again in the theory class. Right? When we consider the second period elements, again, one more time. We are starting from fluorine. Just remember this value. Fluorine's electronegativity value is 4.0 because fluorine is the most electronegative atom. Along that period, 0.5 by 0.5, the electronegativity value is decreased. Then chlorine's electronegativity value is lesser than the one value of fluorine, therefore 3.0. Sulfur's electronegativity value is lesser than one value of oxygen, 2.5. Right? Then here you can see that hydrogen and phosphorus, remember both of them are 2.1. Thereafter, decrease the values by 0.3 by 0.3. 1.8, 1.5, 1.2, 0.9. Right? So this is actually Pauling scale. Now in your resource book, they have given actually a large table. So if you can remember these elements, that's enough. Okay. Now here, can you understand a pattern? Along a period from left to right, what will happen to the electronegativity? As you can see here, electronegativity along a period from left to right, is it increasing or decreasing? It is increasing. Electronegativity increases along a period. According to this one, right? Look at hydrogen, lithium, sodium, beryllium, magnesium, boron, aluminum, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine. Downward the group, electronegativity value is decreasing. Right? Electronegativity value is decreasing downward the group. Now, now you can go for the answer, right? Okay, again, let's get a summary. First of all, atomic radius. Then first ionization energy. Third one is electronegativity. First of all, let's prepare a table how these things are, how these properties are varying along a period, along a group. First of all, along a period. From left to right. Right? Then along a group from top to bottom. Okay. Then atomic radius, what do you think? Along a period? Atomic radius from left to right? Decreasing. Then along a group top to bottom? Increasing. First ionization energy along a period? Zigzag variation. Along a group top to bottom? Decreases. Electronegativity along a period from left to right? Increasing. Along a group top to bottom? Decreasing. These are the variations. Understood? Now, look at the 5 options they have given. Atomic radius, down the group increasing, across a period left to right increasing. Wrong. First one is wrong. First ionization energy increasing down the group. Wrong. Third one, electronegativity down the group increasing. Wrong, right? Because it is decreasing, as you can see here, right? These are the values according to the Pauling scale. Atomic radius down the group increasing, across a period left to right decreasing. Yeah, that's correct. Fourth one is correct. Anyhow, let's go for the fifth one also. First ionization energy down the group decreasing, across a period left to right normally increasing. No, we can't say normal increasing. So zigzag variation, right? We can't see a proper increment there. Increment means definitely the next element should be greater than the previous one. But when we consider beryllium and boron, then oxygen and nitrogen, so there is a difference, right? Then question number 11, answer should be fourth one. Question number 11, answer should be fourth one. Raise your hand, those who got the answers, fourth one. Good, very good. There are some students. Okay. If you want to note down this one, quickly note down. And if you have any doubts, put your doubts in the chat box. Very good. Most of you gave the definition for the electronegativity nicely. Right, okay, are we done? Shall we move to the next question? Let's discuss about what are the factors affecting to the electronegativity and everything in the theory class, okay? Can we move to the next question? Friends, are we done? Done, okay. Students, I need something like this. Soon after the class, now some of the students are watching the recording also. For those students also, I'm telling you that. Now this is the first session. Send me a small message. How is about the first session? How do you feel about the first session? And any requirements you need from this paper class? What kind of things you need the paper class? What are the things you are expecting more from this paper class? Okay, your idea, your opinion. So kind of a feedback, and what more you need in the paper class. Okay, so send me a message after the class. Right, you can send me that message personally. Right, question number 12. Question number 12 is related to the ionization energy, consecutive ionization energies. The successive ionization data of 4 consecutive elements A, B, C, D are given below. Can you remember we did this kind of a question in the memory booster paper also? So 4 elements are giving successive ionization energy values I1, I2, I3, I4 values also given. Then select the groups of A, B, C, D in the periodic table. Look at this one. Element A, B, C, D. And okay, right. So these are the ionization energy values they have given. And they're asking select the groups of A, B, C, D in the periodic table. Students, I told you when you are given this kind of a ionization energy, consecutive ionization energies, you have to first of all separate the energy levels, then sub energy levels. How you can separate these energy levels? By considering the largest energy gap. Okay, by considering the largest energy gap. Now look at this one. First of all, let me start from the D. So you can see that here only the largest energy gap is obtained. That means, students, between these two only, the separation of the energy levels, principal energy levels are obtained. That means you can see that these 3 electrons are belong to one particular principal energy level. Let me consider this is valence shell, and this is belong to the previous one, n minus 1. And here, what do you think? Here you can see that the largest gap is obtained between these two values. Then this belong to one particular principal energy level, and these two are belongs to the previous principal energy level. And what about here? Here you can see that this electron belongs to, so here only the largest gap is obtained. So these two belongs to, we can say that this electron belongs to one particular principal energy level, and these 3 are in another principal energy level, n minus 1. Okay. Right. Students, let's keep capitally. You can get the answer for B, C, D. How? What is the method? In the valence shell, there is only one electron. Then, if there is only one electron in the valence shell, then capital B should belongs to which group? Right? Can you remember group number 1? Group number 1 configuration is S1. Group number 2 is S2. Group number 13 is S2P1. Group number 14 is S2P2. 15 is S2P3. 16 is S2P4. 17 S2P5. And 18 is S2P6. Then tell me, students, capital B belongs to which group? Group number 1. Can you understand? So this is group number 1. And here you can see that 2 electrons are there. That means this is group 2. What about D? Now, when you consider the gap between these two, so here we can say that 0, 4, 9, 940. What is the gap between these two? So here we can consider 75, 6, so 2, 1 in this way. Yeah, 1225, and here the gap is 940. So here you can see the separation of the sub-energy levels, right? Here you can observe the separation of sub-energy levels. Then, if you can see the separation of the sub-energy levels, then what should be? So where you can see the highest gap between these two, right? Then you can understand this electron belongs to one particular sub-energy level, and these 2 electrons are belong to another particular sub-energy level. Let me consider here, this is L and this is L minus 1. Right? So you can see that these 2 electrons are belong to a sub-energy level, and this is P sub-energy. Then okay. Then S2P1, right? We can say S2P1. S2P1. What is the group number? It is group number 13. It is group number 13. Can you understand? Now, students, when we go for the capital A, we don't see very large gap between the values. So therefore, we can say that these 4 electrons are located in the same principal energy level. But we can't exactly tell whether it is, now here 4 electrons are there, no? Whether it is S2P4 or else S2P5 or S2P6. But definitely we are sure that this electron should be in group number 16 or 17 or 18. Because if it is S2P3, then third electron and third ionization energy and the fourth ionization energy, there should be a little bit difference between the, there will be a small difference gap between the other values. So in that case, what is the option that we have to choose here? 1, 2, 13. So there are 1, 2, 13. There are 2 options, second one and third one. But we know that, students, there is no group that we are discussing as 8. 8 group is there. 8 group is in the D block, but we are not discussing about the D block. I told you, right? So therefore, we have to consider this is group number 18. So question number 12, answer should be second one. Raise your hand those who got the answer, second one. Okay, good. Yes, if you have any doubts, ask me. Yes, Ayman, any doubts? Raise your hand those who understood this explanation. Do you have any doubts here? Any doubts? Right, okay. Remember, students, one more thing I want to remind you. When we are doing a question paper, read the instructions very carefully, okay? Especially when you are reading the questions in the last questions, that means question number 31 to 40 and 41 to 50. In the A-level exam paper I'm talking about, the statement type of questions, read them very carefully. Okay? Sometimes they're asking not true, incorrect statement. Sometimes they're asking correct statement, right? So they have bolded that one, incorrect or correct. So you have to look for those things very carefully. Because I know that most of the students are doing silly mistakes, right? They have knowledge, they know what to do, but you are doing a very silly mistake. Sometimes you're not reading the question very carefully, right? Choosing the answer without reading the question carefully. If they're asking incorrect statement, you are choosing the correct statement. Then you answer. Those kind of things will happen to you definitely, right? In future when you're doing the papers. Question number 13. Which of the following is given by the angular momentum quantum number O, azimuthal quantum number? You can correct that one as O, right? Not of. O azimuthal quantum number. So angular momentum quantum number and azimuthal quantum number is giving. Right. Let's see the answers. Orientation of the orbital. Orientation of the orbital is given by magnetic quantum number, right? ML. Spinning of the electron in the orbital, that is given by spin quantum number. Shape of the orbital, yes. Shape of the orbital is given by angular momentum quantum number or azimuthal quantum number. How? Actually, azimuthal quantum number, angular momentum quantum number is representing the sub-energy level. So when we know the sub-energy level, we can tell the shape of the orbital. If it is S sub-energy level, spherical shape. If it is P sub-energy level, we know dumbbell shape. So therefore, third one is the correct one. The number of subshells, right? Students, remember, we can tell the number of subshells, but it's not what meant by the quantum number. Azimuthal quantum number means the definition of that one. Can you remember? I gave you that one as a summary in a table. The definition says that is the shape of the orbital, or else what kind of a subshell is that? Right? It doesn't give the number of subshells. Now there is an electron in the second principal energy level, S sub energy level, then quantum number is 0. But P sub energy level is also there. The number of sub energy levels are not given. Okay, so therefore what one is wrong. The main energy level in which the electrons in the atom are included. That means principal quantum number. That's wrong. So therefore question number 13, answer should be third one. Question number 13, answer should be third one. Raise your hand those who got the answers third one. Good, very good. Okay, right. Now let's move to the question number 14. Question number 14. Which is false regarding the species N3 minus, O2 minus, F minus, and neon, right? Nuclei of them have similar number of protons to the number of protons present in the nucleus of neon. Okay. N3 minus, O2 minus, F minus, and neon. Nuclei of them have similar number of protons to the number of protons present in the nucleus of neon. First of all, how many protons are there in the neon? 10. Then how many protons are there in nitrogen? 7. Oxygen 8. Fluorine is 9. So therefore the first statement is wrong, right? They're asking false statement. Maybe the first one is the answer, right? Let's see other statements also. The radii vary as N3 minus, O2 minus, F minus, and neon. Students, can you remember I told you that when they are forming anions, with the increment of the negative charge, the radius is increasing. Why? If the electrons are gained by forming an ion, electron-electron repulsion forces are created. And the negative electric field is repelling the electrons. So therefore, now you can get the answer by considering the electron proton count also. Here 10, 10, and here also 10, 10. So since they have the same number of electrons, we consider these four species are in isoelectronic series. Nitride, oxide, fluoride, and neon, all of them are in isoelectronic series. So therefore, look at this only. Proton 7, electrons are 10. Proton 8, electron 10. So that the proton count is increasing for this direction, where the electron count is constant. When the proton count increases, what will happen to the nuclear charge? Can you remember the relationship between atomic radius and the nuclear charge? Atomic radius and the nuclear charge, right? When the nuclear charge increases, atomic radius is decreasing, right? So therefore, the largest radius belong to what? N3 minus. So we can see that N3 minus has the largest radius, O2 minus next, F minus. Second statement is correct. Third statement, they are isoelectronic. Yes, if they have same number of electrons, isoelectronic. Fourth one, they have same electronic configuration. Yeah, 10 electrons are there. Then the electron configuration is 1:2:2, 2p6, sorry. That's true. Number 5, their nuclear charge varies as N3 minus nuclear charge. So does nuclear charge means number of protons. Nuclear charge means number of protons. So therefore, the nuclear charge is varying like this. Which one is having the highest nuclear charge? Neon, in this way. So here there are two answers. No, they're asking about the false statement. Number 1, number 5, both are wrong. Question number 14, there are two options. Number 1 and number 5, both. Right? Both are wrong. Raise your hand those who got the answers correctly. Number 1 or number 5. Right. Right, okay. Now let's move to the question of 15. Question number 15. The processes shown by the following reactions are mentioned correctly in, right, X gas producing X plus gas by releasing one electron, Y gas taking up one electron and producing Y minus gas, Z gas producing Z gas plus. Okay. Right. Students, you know the first process actually. What is this process? Tell me the first one. This is considered as capital A. What is the capital A process? That is first ionization energy, right? First ionization. Right? One electron is removed from the gaseous state neutral atom. Then just now we learned, right, in a previous question, electron is gaining. So therefore, this is first electron gain. First electron gain. Okay, now under the electron gain energy, I forgot to tell you that, students, the negative value of the electron gain energy, the negative value of the electron gain energy is known as electron affinity, right? Negative value of the electron gain energy is considered as electron affinity, right? Actually, when we are doing A level, there is a this was very controversial. Instead of the electron gain energy in our resource book, they were giving electron affinity. So when you do very old past papers, electron gain energy is not there, only electron affinity is there, right? So now only they have defined that, they have changed this one. Electron affinity and electron gain energy are two different things, right? So when we calculate the electron gain energy for some particular element, the negative opposite sign of that one is electron affinity. The value is same, right? Value is same, but that is different. Then now this is actually what then? So can you see that this is completely here this one should be Z minus, huh? Correct this one, this should be Z minus. So this is completely opposite of the electron gain energy level, right? If I write down the electron gain energy reaction for this one, so that should be like this. So this is considered as electron gain energy. Electron gain. Then opposite of this one, that means reverse of this one, Z minus gas producing Z gas plus one electron, right? Then what is this? Minus electron gain, that means electron affinity. Electron affinity. Then this is electron affinity, right? A is electron first ionization, B is first electron gain, C is electron affinity. Then now we have to choose the correct answer. Electron gain energy is given in the B, electron affinity is given in the C, first ionization is given in the A. Question number 15, answer should be second one. Question number 15, answer should be second one. Raise your hand those who got the answer. Very good. Now tell me, out of 15, what is the mark you got? Out of 15. Anyone got 15 out of 15? Raise your hand, those who got 15 out of 15. Ifasa, Abhita, Senuki, Pushma. Good. 14 out of 15. Shehani, Joella, Zainab. Good. And others, you can put your marks in the chat box. Okay, I'll be the 13. Quite good. Normally in the first term examination, remember students, in your first term examination, the maximum number of MCQs they will give you is 25. 25 MCQs will be given. Okay. Now, out of 15, if you can score 13, 14, 15, like, then you are in a good level. Yeah. Answer? Good. Right. So this is what we have to discuss on the first 15 questions. Right up. Okay, students, what are the doubts you have? Any doubts that you want to ask? Anything? Right, okay. Then students, these are the things that we have to discuss today. As I said you, after the class, send me a message about the first session that we conducted today. So what about these things that we discussed today? All clear, super clear? Raise your hand those who understood the things that we discussed today. The reverse process is negative electron gain energy. Yes. Now for an example, now just imagine electron gain energy value for this one is 100 Then the reverse process is minus 100. Electron affinity is minus 100. Understood? Akira? Right. Okay, students, then from the next week onward, so you will be added to the paper class group separately, for those who registered for the class. And I'm sending the paper book also next week. So you will receive this one, those who registered for the class. And so hereafter, every Saturday, 1 p.m. to 3:30 p.m. Sometimes this time might be expanded to 4 p.m. little by little. So 1 p.m. to 3:30, right? That is the fixed time. Sometimes 1:30 to 4 p.m. in that way. So we are going to continue in this way. So you will meet a lot of very interesting questions, difficult questions that you have to prepare for the exam, right? So these are the things that I wanted to tell you. Then memory booster paper. I'll put a separate time slot for the memory booster paper, and I'll let you know about that one in the next week. Okay. So what we are going to do with the memory booster paper. Along with this one, we have to do that one also, because we want to revise the we want to do a weekly revise. So that's why I'm conducting the memory booster paper discussion. So let's do that one also, right? Then students, anything else? Any doubts? Any other doubts that you want to ask? Sorry. Okay, then students, I'm going to wind up the session for today. So we are going to meet on the next week class at the same time, 1 p.m. So next week we are going to finish unit number 1, and we are starting unit number 2 in August now. Okay, right. Then let's meet on the theory class. Until then, bye bye. Have fun. Good evening for all of you. God bless you.